Hey buddies, how we doing? Let's take a look at how we can uh, actually evaluate functions at expressions beyond just points. That's the idea today, okay? Before we do anything, take a look at this function. F of x equals 2x plus 3, right? What does this really mean? Well, let's think. It means if we plug in anything here, f of x, right? Anything that goes in here, well, that really gets multiplied by 2, and then we take our result and add 3. So this is really like a placeholder. It's just an object, right? F of anything equals 2 times that thing plus 3, okay? So, and if you want, you can think about it like this. F of square equals 2 times the square plus 3, right? Technically speaking, that's what you do if you would plug in a square into this function, right? It's just a placeholder. So keep that in mind when we look at these, okay? Now, obviously, I know, like, we've done f of 5, right? That's what's going into our function. So we do 2 times 5 plus 3. That one's just going to be a number, right? 2 times 5 plus 3 is what, 13? Right? 10 plus 3, 13. Perfect. Same thing with negative 2. Right? You can plug in negative 2 into your function. Negative 4 plus 3, negative 1. So we plugged in a number, got out a number. Now, this is when things start to get a little different. You might be looking at that happy face already thinking, what is going on? But think about if you didn't plug in a number. Let's say you plugged in k. Right? Well, technically we would do the same thing. We would do 2 times whatever that k is, right? Plus 3. Kind of like the square. It's almost exactly like the square, it's just a k instead, right? So you're just taking that number, whatever that is, that variable k, multiplying by 2, adding 3. We can't do anything else with this. It's not a number, right? So we just leave it, right? What if we put in a happy face, right? I'm going to use red just as continuing the theme, right? Well, again, the function here, the function rule is saying take 2 times whatever you plug in and add 3. So it's 2 times the happy face. I'm going to do my best job here at drawing that happy face. That's pretty good. No? Yeah, it's not bad. 2 times the happy face plus 3, right? Now I know it makes no sense, right? We're not going to ever do that in a math problem, plugging in a happy face, but that's the idea. It's whatever is in that parentheses is what is being inputted into the function. And remember, this is the input, right? Whatever it is, you're doing 2 times the input plus 3. So these are the ones, the last two here are the ones we really want to focus on today. If you plugged in x plus 4 into this function, that entire thing is the input. You're putting that whole thing in there. So, following the pattern, right, it's 2 times the input, which is x plus 4 plus 3. Okay? Don't overthink it. Right? This is the entire like blob. It's the happy face. It's the square. The x plus 4 is the input. Okay? Even though it's an expression and not just a number. Right? Now you guys know how to simplify this. Alright? We're just going to get some good practice with that. We need to distribute. So we get 2x plus 8 plus 3. Which is, what? 2x plus 11. Right? So plugging in and substituting in x plus 4 in that x spot gives us that. All right, you guys can go ahead, try to do the same thing with 5x minus 1. Okay, so again, this is our input. We add our 3, distribute, 10x minus 2, and then plus 3, we should get 10x plus 1. Okay? Cool. So we plugged in expressions and we got out other simplified expressions. That's the name of the game. Okay? Let's take a look at another one. Okay? I'll let you guys do these first two. Okay. Don't let the W here throw you off too much. We'll use a different color just for fun. Remember, this is the input. It can be whatever, right? It could be whatever variable. This is the input. So what we're saying is take the input, square it, and then minus 6, right? So in this one we get 4 squared minus 6 is 10, because you get 16 minus 6 is 10. Negative 3 squared minus 6 is 3. You get 9, right? Positive 9. Careful about that. Positive 9 minus 6 is 3, right? Now, ooh, little cat guy there. I like that little cat guy. Let me see. I'm going to do my best to draw that, but that's our input, right? I'm just thinking the thing in parentheses is the input. Ooh, made him green. That is my cat. Not the greatest. Trying to do the same sort of picture. It's kind of close, I guess. No, sorry. I did my best. And that we can't really simplify, right? That's as far as we can go. I just plugged in the cat where I saw the placeholder, right? Okay, g of 2x. Now that whole thing goes in here. So 2x squared minus 6. Now this we can simplify further, right? So I just plugged in the 2x where the input was. Wherever I saw w in this expression, right, that's the input. And we get 2x times 2x, that's 4x squared, right, minus 6, right? And just think of 2x squared as 2x times 2x. Right? If you maybe left out off the squared or left off the 4, okay? It's 2x times 2x. Okay, so we simplified that. Let's try x minus 3. Now, talked about this a little bit before when we did multiplying, but we're going to plug that whole thing into x minus 3 squared minus 6. So that whole thing is being squared. Again, can't stress this enough. Before you even do anything, really look at what the function is telling you to do. It's telling you to take anything inside that parentheses, square it, and minus 6. Now we have to remind ourselves, if you square something like x minus 3, technically you are doing x minus 3 times x minus 3. Not x squared minus 9, right? It's not just applying that squared to both, right? You actually have to multiply x minus 3 times x minus 3. You could do this with double distribution now, if you wanted, or you could do quick area model. Either one is fine. I'm going to go with the area model. Zoom in here for a second. So x minus 3 times x minus 3, then there's a 9. I have some like terms here. So I get x squared minus 6x plus 9, right? That was from this whole thing. Don't forget that about that minus 6, but we just simplified that whole part. So x squared minus 6x plus 9, and now we're going to subtract the 6, right? So we don't want to forget about this part, right? Every time we're doing this function, we're squaring the input and subtracting 6. And now I have some like terms here, right? A 9 minus 6, so I get x squared minus 6x plus 3. Okay? Okay, I'm going to let you guys try 4 minus x. All right, go for it. Okay. So hopefully we set this up. Pretty well. Okay. I'm going to do my 4 minus x times 4 minus x. Right? Do an area model or double distribute. I'm not going to tell you one way or the other. It's whatever your preference is. And then we get a positive x squared down here, right? So I got 16 minus, got some like terms here, minus 8x plus x squared, and then minus 6 again. So I'm looking here, I got 16 and negative 6. That combines to be 10. Minus 8x plus x squared. Oops. Okay. Technically, if we wanted to write that in standard form, right, good habit to, pen's not working great. We would want to write that as x squared minus 8x plus 10. Let me reset. Get the pen working.